All right, this is the last section of Unit 3, and this is average rate of change. Now, you've done stuff like this last unit towards the end, so this should be more of a refresher. All right, so average rate of change. This should be familiar right here, the formula. All right, so it's basically slope. You've heard me use that term, rise over run. You may have heard that, which is the same thing as a change in y over a change in x. So if you're given 2 points, you just have to subtract your y's and your x's. So remember, y's go on top. Y's on top. All right. So, and again, this is also known as slope. So how can you identify the rate of change? So here you have 2 points, basically. You have a table, and your points would go like this. You have those and those. So 0, 3, and 2, 2 are points. Okay. And remember, m, which is slope. Okay. That's the same thing as, and this means change in f of x or y over change in x. Okay, so make a note of this. This is the same as y. All right, so in this case, the slope would be take your y's, which are on top. Order that you subtract them in really doesn't matter as long as you subtract your y's in the same order as you subtract your x's, or vice versa, however you want to look at it. So 3 minus 2, and that's going to be over. And since we did 3 first, we have to do 0 first. 0 minus 2, which gives you negative 1/2. And notice, because this is a positive 1, and this is a negative 2. So we just put the negative sign out in front. Okay, so we're going to use this formula in 3 ways. When you're given 2 points, such as 3, 4, and 1, 5. When you're given a table, which you can see is the same way of representing this. And then finally, when you're given a graph. So if you have a graph, basically the line would connect the 2 points. So let's try a practice problem. We want to calculate the rate of change for a line that passes through these points, 2, 3, and 1, 2. So again, remember this. Okay, slope equals the difference in y's, or f of x, over the difference in x's. So we can pick this one first. We're going to do 3 minus, not that one. Sorry, pen slid a little bit. 3 minus 2 on top. And then since we did that, on the bottom, we have to follow the same order. 2 minus 1. So 2 minus 1. And that's going to give you 1, because 3 minus 2 equals 1, and 2 minus 1 equals 1, and 1 over 1 equals 1. So let's try an example. We've got 2 points, negative 4, negative 8, and negative 6, 12. So again, remember, you are going to subtract your y's and your x's in the same order, and the y's need to go on top. So let's start with the bigger number, 12, and we're going to do 12 minus, because it's always subtraction, negative 8. And if it helps, put parentheses around that. Okay? And then that's going to be over, since we did 12 first, we have to do this first, and then these are our second numbers. So negative 6 minus negative 4. Now remember, when you're subtracting a negative, this actually becomes plus a positive. So that becomes 12 plus 8, which equals 20. And negative 6 plus 4 comes out to be negative 2. And 20 divided by negative 2 is negative 10. Okay, now if you're given a table like this one, make sure you're looking at the table first, because again, make sure you know what your x's and y's are. When your table goes like this, x is on top, y is on the bottom. All right, so as time passes, what's happening to the number of gallons that are evaporating? Well, you've got your hours, 3, 7, so time's going this way, right? And the number of gallons that are evaporating are increasing. So the number is increasing. So we should have a positive slope, meaning when you figure out your slope, the number should be positive. So let's actually try and figure out what that rate of change is. So you can pick any 2 y's or x's you want. But again, make sure you pick them in the same order. So we're going to call this one 1, which means we're going to have to use this one for our x's. We're going to do 5.5 minus 14.5. So this is going to be 2, and that's going to be 2. So if we do 5.5 minus 14.5, then on top, we have to have 3 minus 7. 5.5 minus 14.5 is 9, is actually negative 9. 3 minus 7 is negative 4. The negatives, if you have a negative on top and on bottom, they cancel out and become positive. But you're not done. You actually have to divide 9 by 4 to get a decimal answer. So 2.25 gallons per hour. So you try one on your own. We've got the same type of problem. We want to find out the rate of change, or the rate at which the gallons are evaporating per hour. So I'm going to pick 14, which means I'll have to pick 10 for my x's. And then 6.5. So we'll have to pick 5. So 10 minus 5. And that's going to give me a positive 7.5 over a 5, which when you divide it, comes out to 1.5 gallons per hour. All right, now graph. As time passes, what's happening to the amount of dollars? Well, time is down here. Amount in dollars is over here. So time's going this way, okay? So as time's passing, the amount of dollars is decreasing, which means that your slope is going to be negative. So the graph and the table should clue you in as to what your slope should be. So let's say I wanted to find out the rate at which it was decreasing. So you take your, and let me change my color so you can actually see here. Let's do red. So you take your y's. Okay, so we've got, let's make this 1, and that's going to be 2, which means we'll have to use that 1 and that. So we're going to do 1,000 minus 800, because those are the y values and those are on top, and then that's over 2 minus 6, which is going to come out to 200 over negative 4, which reduces to negative 50. So the amount of money in the account is decreasing, and that's because it's a negative number, at $50 every week. So even though it's a negative 50, we just say it's decreasing at a rate of $50 every week, not decreasing at negative $50, because that doesn't make any sense. All right, so in this example, I'm going to make this 1, 1. So my x is going to have to be that one, and then this is going to be 2, so that one will have to be 2. So I'll do 8,000 minus 2,500, and that'll be over 18 minus 6, and that's actually wrong. This should be 6 minus 18, which will give me negative 5,500 over 12, because this is 5,500 positive, and that's a negative 12. So we do the division on that, and we get that the amount of money in the account is decreasing at a rate of $458.33 every week. Okay, now, with linear functions, the rate of change is constant. It will not change from point to point. So this is a linear function. Okay, because everything forms a nice straight line. This is not a linear function, because your points are all over the place. All right, so like in this one, is percent usage a linear function of age? So meaning, what that means basically is, if you look at this graph here, is this a function? And the way that you tell that is, okay, well, what's the difference? These are each going up by 1 every time. So if that's the case, it's nice and easy, because then these should be going up by the same amount every time, or down, or whatever. So 41 to 56, that's plus 15. 56 to 64, that's plus 8. So right there, that tells you that that's not a linear function. You can still find the rate of change from, between 2 points if it asks you the average rate of change. Like in this case, what's the average rate of change from age 13 to age 15? Well, these are your x's, these are your y's. When a column that goes up and down, x's are on the left, y's are on the right. So remember, we have y1 minus y2, or vice versa, however you want to look at it, So I'm going to pick, I'm given my x's actually, 13 and 15. So I'm going to do 13 minus 15. And since I did that, if I did that first and that second, that means that this has to be first and this has to be second. Doesn't matter. You could do it either way. So 13 minus 15, and this is 41 minus 64. 41 minus 64 is negative 23. 13 minus 15 is negative 2. So then you would divide that and get a positive number, and that would be 11.5. And that would be the average rate of change. Okay? So all you're doing here is you're using the same formula over and over again. The only thing that's kind of different is this right here. And you can tell that just by checking to see if this is increasing at the same rate at each time. So last example, is percent usage a linear function of age? Well, here we went down by 7. Here we only went down by 1. Then we went up by 4. So no, not a linear function. If they were the same, it would be. So again, if you check every one of them and they're the same, then it is a linear function. So what's the average rate of change from 13 to 15? So again, we're going to have, let's do it differently. We'll do 15 minus 13 this time. That's going to be a positive 2. Since this was 1 and this is 2, I have to use this and that. So 59 has to be first minus 67. So that's going to come out to be a negative 12, which will give me an answer of negative 6. So negative 6 is your average rate of change. All right? So that's it for this unit. This one's a little bit harder, so make sure you go through this and take some really, really good notes. So some tips. Remember the formula for rate of change. Make sure functions are linear, and take your time. And that's it. Have a good one.